Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for more science, space and tech news to share with you. Came across this at Scientific American. Yes, evidence of negative time found in quantum physics experiment. This should be interesting. Physicists showed that photons can seem to exist in a material before entering it, revealing observational evidence of negative time. Absolutely fascinating. Yeah, I'm not a scientist myself. I just love sharing, all science, space, and tech news, and obviously been a sci-fi fan since I was a kid. So we're starting to see evidence of, time travel, something finishing before it even starts. This is absolutely fascinating. Quantum physicists are familiar with wonky, seemingly nonsensical phenomena. Atoms and molecules sometimes act as particles, sometimes as waves. Particles can be connected to one another by a spooky action at a distance, even over great distances, and quantum objects can detach themselves from their properties, like the Cheshire Cat from Alice's Adventures in Wonderland detaches itself from its grin. Now, researchers led by Daniela Aguilo of the University of Toronto have revealed another oddball quantum outcome. Photons, wave particles of light, can spend a negative amount of time zipping through a cloud of chilled atoms. In other words, photons can seem to exit a material before entering it. That's fascinating, isn't it? Now, as usual, I'll leave the link to the main article below the video, so you can pop in, check out these embedded links, go for a bit of a deeper dive if you want. It makes for an interesting read, believe me, beyond the main article. It's fascinating. It took a positive amount of time, but our experiments observing that photons can make atoms seem to spend a negative amount of time in the excited state is up. Yes. Now, wrote Aferim Steinberg, sorry if I've mispronounced your name there, a physicist at the University of Toronto, in a post on X, formerly Twitter, about the new study, which was uploaded to the preprint server, archive.ph, which I can never pronounce anyway, because obviously I'm not a scientist, but I just love this stuff, on September 5, but has not yet been peer-reviewed. Now, the idea for this work emerged in 2017. At the time, Steinberg and a lab colleague, then doctoral student Josiah Sinclair, were interested in the interaction of light and matter, specifically a phenomenon called atomic excitation. When photons pass through a medium and get absorbed, electrons swirling around atoms in that medium jump to higher energy levels. When these excited electrons lapse into their original state, they release that absorbed energy as remitted photons, introducing a time delay in the light's observed transit time through the medium. That's absolutely incredible, isn't it? Sinclair's team wanted to measure that time delay, which is sometimes technically called a group delay, and learn whether it depends on the fate of that photon, which is scattered and absorbed inside the atomic cloud, or was it transmitted with no interaction whatsoever? At the time, we weren't sure what the answer was, and we felt like such a basic question about something so fundamental should be easy to answer, Sinclair says. But the more people we talked to, the more we realised that while everyone had their own intuition or guess, there was no expert consensus on what the right answer would be. Because of the nature of these delays, can be so strange and counterintuitive, some researchers had written the phenomenon off as effectively meaningless for describing any physical property associated with the light. That's absolutely fascinating, isn't it? I've often wondered, from science fiction like Star Trek Deep Space Nine, when they're talking about the wormhole aliens, or the Bajoran prophets, as they were called, these particular characters, where they had a problem. These particular beings had a problem with humans and lineal time. Now, that to them time meant nothing. It didn't make any sense to them. We have a past, present, and future. To them, that concept was completely foreign to them. And, it could be a week, it could be a day, it could be a month, it could be centuries. It didn't seem to make any difference to them. They just had no idea what time was. Absolutely fascinating.
Linear time. What is this?
My species lives in one point in time. And once we move beyond that point, it becomes the past. The future, all that is still to come, does not exist yet for us.
Does not exist yet?
That is the nature of linear existence. And if you examine it more closely, you will see that you do not need to fear me.
Now, I've got a little bit of a video clip here on, because I'm a sci-fi fan, on a little bit about, because I can, time travel. Let's check it out, and we'll carry on the conversation when we come out the other side.
Hey there, sci-fi enthusiasts. Buckle up, because today I'm diving deep into the mind-bending world of time travel. From ancient myths to cutting-edge science, let's unravel the mysteries of bending time itself. Time travel has fascinated humans for centuries. Stories from H.G. Wells' The Time Machine to movies like Back to the Future have captured our imaginations. But what does science say about it? Einstein's theory of relativity is the cornerstone of modern physics. It tells us that time and space are interwoven into a single continuum known as space-time. According to Einstein, if you travel at speeds close to the speed of light, time slows down for you compared to someone who remains stationary. This is time dilation, a real-life form of time travel. But what about traveling to the past or far into the future? Here's where it gets tricky. Wormholes, hypothetical tunnels connecting distant points in space-time might offer a solution. Imagine folding a piece of paper and poking a hole through it. That hole is the wormhole, theoretically allowing you to traverse vast distances or even times instantaneously. However, there are potential dangers. The grandfather paradox is a classic dilemma. What if you traveled back in time and prevented your grandparents from meeting? Would you cease to exist? This paradox hints at the complex and potentially hazardous nature of altering timelines. Could we ever build a time machine? Some physicists, like Kip Thorne, believe it might be possible, but it would require exotic matter with negative energy density. And, as of now, such materials are purely theoretical. In fiction, we see time travel portrayed in myriad ways. Shows like Doctor Who and Dark explore the consequences of meddling with time. They often highlight how delicate the balance of events can be. Let's not forget the ethical implications. If time travel becomes a reality, who controls it? Could it be used for good or evil? The potential to alter history is immense, and with great power comes great responsibility. Whether time travel remains in the realm of fiction or becomes a scientific reality, it continues to captivate our minds and fuel our imaginations. Don't forget to like, subscribe, and hit that bell icon for more fascinating explorations into the unknown. Until next time, keep dreaming big and thinking even bigger. See you in the future or the past. Stay curious.
Well, that was very interesting, wasn't it? Again, I know it's all science fiction, but how much science fiction has turned out to be science fact? I mean, have a look at the original Star Trek with its flip phones.
Correct, here.
It's communicators. Next thing you know, 3 decades later, we had flip phones. I mean, have a look at the replicators that can literally make drinks, food, physical objects out of nothing.
Talk. I'd like me a thick Kansas City steak and some country fried potatoes and a mess of greens. Oh, hell, just forget all that and give me a martini straight up with 2 olives for the vitamins.
And everyone goes, well, that's just science fiction. Now we have 3D printers. NASA, I believe, is working on 3D printers to be taken into space for producing basic food items. Yeah, for the next incarnation of the International Space Station.
Only time will tell, my friends.
Absolutely amazing, isn't it? Yeah, science fiction becoming science fact. And we're seeing the same thing here. We're talking evidence of the ability to, for having an event happen before it happened. It's fascinating. I think it's absolutely amazing. After 3 years of planning, his team developed an apparatus to test this question in the lab. Their experiments involved shooting photons through a cloud of ultra-cold rubidium atoms and measuring the resulting degree of atomic excitation. Now, 2 surprises emerged from the experiment. Sometimes photons would pass through unscathed, unscathed, yet the rubidium atoms would still become excited, and for just as long as if they had absorbed those photons. Now, stranger still, when photons were absorbed, they would seem to be remitted almost instantly, well before the rubidium atoms are returned to their ground state, as if the photons on average were leaving the atoms quicker than expected. As I say, not a scientist, just love sharing all science, space and tech news with people, but if there are any physicists out there, can you please comment on this and share your thoughts? Because we'd love to hear from somebody who actually knows a lot about this. It would be fantastic. Thank you. The team then collaborated with Howard Wiseman, a theoretical and quantum physicist at Griffith University in Australia, to devise an explanation. The theoretical framework emerged showed that the time these transmitted photons spent as an atomic excitation matched perfectly with the expected group delay acquired by the light, even for cases when it seemed as though the photons were remitted before the atomic excitation had ebbed. Now, to understand the nonsensical finding, you can think of photons as the fuzzy quantum objects they are, in which any given photon's absorption and remission through an atomic excitation is not guaranteed to occur over a certain fixed amount of time. Rather, it takes place across a smeared out, probabilistic range of temporal values, as demonstrated by the team's experiments. Now, these values can encompass instances where an individual photon's transit time is instantaneous, or bizarrely, when it concludes before the atomic excitation has ceased, which gives a negative value. Now, I can promise you that we were completely surprised by this prediction, Sinclair says, referring to the matchup between the group delay and the time the transmitted photons spent as atomic excitations. And as soon as we were confident we hadn't made a mistake, Steinberg and the rest of the team, I had moved to a postdoc at the Massachusetts Institute of Technology by this point, began planning to do a follow-up experiment to test this crazy prediction of negative dwell time and see if the theory would hold up. Now, that follow-up experiment, the one led by Agulo at that Steinberg touted on X, can be understood by considering the two ways a photon can be transmitted. In one, the photon wears blinders of sorts and ignores the atom entirely, leaving without even a nod. In the other, it interacts with the atom, boosting it to a higher level of energy before getting remitted. Wonder why it does that, why it chooses to do that. Or is it just completely random? Or does it have some form of some sort of, sentience, and it knows when and where and why and how? That's absolutely, in order to do that. That just fascinates me. Now, when you see a transmitted photon, you can't know which of these occurred, Steinberg says, adding that because photons are quantum particles in the quantum realm, the two outcomes can be in superposition. Both things can happen at the same time. Sounds very 1984, doesn't it? Doublethink, where you can think two contradictory things can be true at the same time. Yes, the measuring device ends up in a superposition of measuring zero and measuring some small positive value. But correspondingly, Steinberg notes, it also means that sometimes the measuring device ends up in a state that looks not like zero plus something positive, but like zero minus something positive, resulting in what looks like the wrong sign, a negative value, for this excitation time. That's absolutely fascinating, isn't it? So we now produced an experiment that proves that something can finish before it even starts.
My brain hurts!
Sounds like me and my sex life. Fascinating. And a little bit worrying too. Well, that's absolutely interesting, isn't it? We now have evidence of negative time found in quantum physics experiments. This is absolutely incredible. Again, I'd love to hear your thoughts on this. It'd be absolutely amazing to hear from you. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video. I'd love to hear what you think. All right, take care, and as I always say, if you can't be good at it. And as I also always say,
fascinating, but quite impossible.
Bye.